Hi, and welcome to the SCS New Faculty Introduction Series. I'm John Zimmerman. I'm the Tang Family Professor of AI and HCI. I'm a professor in the Human-Computer Interaction Institute, and I have a training as an interaction designer. My work focuses on human-AI interaction for professionals, really looking at how we can blend human and machine intelligence together. And then I also do some work on social robots and on the idea of using AI as a design material. This is the fourth event in the School of Computer Science New Faculty Introduction Series. And this series is all about introducing the SCS community to our newest faculty members. That's something that's obviously really hard right now, to get to know each other when we're all working from home because of the pandemic. We really encourage you to participate by asking questions using the question answer function built into Zoom. And we're going to do our best to answer all of the questions live. Today, we're going to be meeting Assistant Professors Motahhare Eslami and Hoda Heidari. Motahhare completed her PhD at the University of Illinois at Urbana-Champaign, working with Carrie Carajalios. Her work focused on algorithmic opacity and transparency. After finishing her PhD, she spent a little less than 2 years working at Facebook before joining the HCI Institute as an assistant professor last summer. And she's been doing some really interesting work on algorithmic bias. Hoda completed her PhD at the University of Pennsylvania, advised by Michael Kearns and Ali Jadbabi. Her work focuses on fairness in automated online platforms. She was a postdoc fellow at ETH in Zurich and also at Cornell. And she also joined SCS this summer with an appointment in the machine learning department and also in the Institute for Software Research. She's doing some super interesting work on the societal aspects of AI, really looking at fairness and explainability. So we're going to be watching two short videos that give us an introduction to each of these two faculty members, and then we're going to open it up for some questions.
Hi, I'm Motahhare, and I'm a new faculty at the School of Computer Science, the Human-Computer Interaction Institute, as well as Institute for Software Research. So my background is in computer science, particularly learning how users interact with opaque algorithmic systems and how we can build a better and more informed interaction with them. So as I said, our work is about responsible AI, meaning that we try to support enough transparency and bias awareness in AI systems. So today, algorithms are taking over the world. They tell us what to read in our social media or news media. They tell us what to watch, what to read, or even whom to date. And while they are usually hidden in black boxes for several reasons, such as protecting intellectual property or avoiding malicious users from gaming the system, such black box nature can cause several issues, including misinformed behavior, which is a behavior that users can show when they are not well informed about how they are consuming information online, and that can cause consequences because of this lack of awareness. So in my research and in our group, we try to investigate users' interaction with opaque and potentially biased AI systems in order to create new designs and build new systems that communicate this opaque algorithmic process to users and then provide them with a more transparent and informed interaction. A few examples that you see, small thumbnails here, is that a tool that we built to show users how their Facebook newsfeed would look like if there was no filtering algorithm at work, filtering their friends' posts. Or how would a transparent advertising system would look like when the advertiser actually tells users why they are targeted with that ad. Or in an online rating platform like Yelp, if a tool was there to tell people which are their reviews are actually filtered by the Yelp rating algorithm. So these are alternate designs for the existing algorithmic systems to help users to have a better interaction with the system. And in continuing this line of research, right now we are focused on two work, which is
about collective audit and designing for high-stake public algorithmic systems. Collective audit is about harnessing the power of regular users in detecting and reporting algorithmic biases. So to give you an overview of what is algorithmic auditing, this is an area that during recent years had got a lot of attention from researchers, developers, activists, or even governments trying to find or detect biases in AI systems that can harm a group of people. But this line of research usually needs a third-party intervention. It can't just be done without experts. However, previous work has shown that regular users sometimes can be even more powerful than these third parties in detecting biases. In one example, as you see here, users of Booking.com, one of the largest hotel rating platforms, found that its algorithm is skewing the ratings higher that shows a better picture for hotels with low to medium quality. In another example on Yelp, users started to discuss its filtering algorithm and how it can cause problems for businesses that do not advertise with Yelp by filtering their good reviews or unfiltering their bad reviews. So based on this history, in collaboration with a group of other faculties at Carnegie Mellon and a great group of students, we are trying to build a platform that actually allows users to do collective audit together in an everyday system they use, find the biases, report them, and hopefully make a change in the real world. The second line is about designing for high-stakes public algorithmic systems, which is about those public algorithms that have high stakes for users, and then they can actually inflict harm on some communities and how we can mitigate those harms. Some examples are predictive policing algorithms, which some of you might know that during the recent protests in Pittsburgh, it was put on a pause because there was a racial bias going on in the data set that it used. The other examples are medical AI systems that doctors use for diagnosis, welfare resource distribution systems trying to see who should stay on some of the government support like Medicare or who should be put on a list to stop getting that support. And also facial recognition algorithms that can decide who put on jail, which recently has shown to be, again, racially biased. So in all of these public AI systems, which have real-world immediate impacts, our goal is to center bias awareness in the design of the systems, meaning that we tell the users of the systems, whether they are judges using pretrial risk assessment tools or police officers trying to decide who put to jail, that these systems are as prone as bias as human, even more, and they need to consider that when they are making a final decision. And with that, I'd be happy to have a chat with you for potential collaboration opportunities if you are interested in this area or just if you want to know more about that. Thank you.
Hello, everyone. My name is Hoda. I am an assistant professor at the machine learning department, and I also have a joint appointment at the Institute for Software Research, where I'm associated with the social computing program. So today I'm going to tell you a little bit about my research, both at a high level, and I'm also going to dive a little bit deeper into a particular area of my research interest. Okay, so the primary goal of my research is to examine the societal and economic aspects of artificial intelligence and machine learning through an interdisciplinary lens, bringing tools and ideas from computer science, including machine learning, HCI, and algorithms, and on the social science side, economics, political philosophy, and beyond, to examine these increasingly important issues. So today I'm going to talk a little bit about a particular ethical and societal concern that my recent research has focused on, and this is the issue of unfairness in the outcomes or predictions produced by machine learning-based decision-making systems. And this comes up frequently when machine learning technology is utilized to make high-stakes decisions for human beings in a wide range of domains. So just in case, let me at a very high level first tell you what machine learning is, or at least supervised learning, which is a special type of machine learning. So here is at a high level how machine learning works. So feel free to ignore the notation. So we basically have access to the historical data records on individuals and their the decision or the outcomes they have received. This, for example, could be whether a criminal defendant reoffended or not. And so for each individual, we have access to some of their features and their outcome or decision. Now, what a learning algorithm does is basically use this data to find or fit a predictive model to the data so that this fitted model has high accuracy in terms of predictions it makes for future individuals. Now, this predictive model is then used to make predictions, which would be the basis of certain decisions for new human subjects. Decision subjects, and the decisions that the machine makes for individuals in turn impacts them and allocates a certain notion of benefit or harm among them, depending on the context at hand. So my work has mainly focused on a particular type of unfairness through machine learning, which I refer to as outcome unfairness. And it is basically concerned with inequities and disparities that arise when the machine learning system makes predictions that distribute some immediate notion of harm or benefit to people who are directly subjected to it. So disparities of this form could come about at different stages of the machine learning pipeline. For example, it could be because the data or the historical decisions are biased, but this is not the only way that we could have bias or unfairness through machine learning. So to give you a concrete example, the type of unfairness that my research focuses on has been recently at the center of several controversies in the public sphere. For example, many of you may have heard about the machine bias article by ProPublica, which investigated a criminal risk assessment software called Compass. And this tool is widely used in courtrooms across the US, and it informs sentencing decisions for criminal defendants. Now, the article by ProPublica claimed that Compass scores are biased against Blacks, meaning that the percentage of African-American defendants who are falsely classified as high risk by the tool is much higher than the same quantity for white defendants. Now, studies like these have motivated an active area of research into quantifying and guaranteeing fairness for machine learning, which is often referred to as FairML, and my work has contributed to this literature. So the literature has proposed various mathematical formulations of fairness and different algorithmic interventions to improve fairness through machine learning. So it has been shown that simultaneously satisfying mathematical formulations of fairness is impossible. So motivated by these methods and results, my recent research has aimed to address two key sets of questions. So the first set of problems that my work addresses is concerned with formulating fairness. How should we determine the proper formulation of fairness given the decision-making context at hand? And this question is important given that we cannot simultaneously satisfy all the notions of fairness. So to make the question a bit more concrete, let's say we want to define group level fairness as the equality of some notion of harm or benefit across socially salient groups. One question that we need to address is how should we appropriately quantify the relevant kind of harm or benefit given the particular application domain and societal context at hand. So the second set of problems that my research addresses pertains to measuring unfairness. And this is assuming that we have already quantified the relevant type of harm or benefit, and we now would like to compare different models in terms of how unfair they are. So these are the two key questions that my prior work attempts to address. Now I will next tell you very briefly about some of this research that I've conducted in the past. So let's first talk about the question of fairness as equality of what. So in a recent paper, my collaborators and I took a descriptive approach to this question and attempt to answer the following question. which of the existing group level mathematical formulations of fairness best matches people's perceptions or intuitions about fairness in specific decision-making contexts, for example, in the context of criminal justice, in the context of criminal risk assessment. Here, we conducted a series of adaptive human subject experiments utilizing certain techniques called active learning tools from machine learning to provide an answer to this question. Let me also showcase one of my work on the issue of measurement. How do we measure unfairness? So let's assume that we all accept the conception of fairness as some form of equality. The question that we would like to answer is, how can we come up with a general measure of unfairness, presumably unfairness as inequality? And this allows us to compare various unfair alternatives and determine which one is the worst. This is practically often more useful than aiming for absolute fairness according to a certain measure of fairness. Now, one of the core ideas we had here was to employ existing measures of income inequality from economics to measure the overall unfairness of a classifier in an axiomatic, well-justified manner. And importantly, a certain mathematical property of our proposed measures allows us to gain insights into the inherent tensions between fairness at the level of social groups and fairness at the level of individuals. So with that very brief overview of what I've been up to so far, let me also talk a little bit about my future research directions. So one critical problem that I'm going to focus on in the next couple of years is the formal study of various sources of bias through machine learning. As I mentioned early on, it is widely accepted that machine learning can imitate past injustices encoded in the training data and as a result produce unfair predictions, but that's not the only source of unfairness. So understanding all these various stages in which we can have bias creep into the system, I believe is very important. Another important direction is to design and study effective ways of comparing and combining algorithmic or machine learning-based decision-making with human-based decision-making and combining human judgment with machine judgment to get the best of both worlds. And this requires us to have a much better understanding of the psychological processes that are at work behind the scene when people go about making their decisions. And last but not least, the societal implications of automated decision-making goes well beyond concern for unfairness and discrimination. And I plan to extend my research inquiry into broader notions of justice, including procedural justice and social level justice. And there are also a whole host of other legal requirements that are in place now for machine learning systems. For example, GDPR prescribes numerous rights for decision subjects, including the right to transparency, the right to rectification, erasure of their data, and so on. So the question here is, can we mathematically capture any of these requirements, and can we at least partially automate the process of complying with them, given the scale at which these decisions are being automated? So hopefully this gave you a flavor of the type of research that I do. Thanks a lot for listening, and I look forward to the Q&A and our discussions.
Okay, I'd like to invite Hoda and Motahhare to turn on their cameras. Yep, they are back. And so great to get a little bit of background on the kind of work that you guys both are doing. It's really an interesting overlap. Okay. I wanted to find out a little bit more. How did you come across this topic? Like when you're starting your PhD in computer science, what made you say this is what I want to work on? Hoda, do you want to take this first?
Sure, yeah. So I was always very interested on the one hand in social sciences, and in particular all the nuances and complexities of social systems. And on the other hand, I was always a big fan of mathematics and computers. So that was how I ended up doing my PhD in computer science, but in a lab where the focus was questions at the intersection of computer science and economics. And actually, one of the earlier projects I started working on was this issue of fair allocation of tasks in systems such as Amazon Mechanical Turk, or in generally speaking, in crowdsourcing. And sort of that was the beginning. Towards the end of my PhD, a lot of these stories came up about how the use of machine learning in socially consequential domains could have unintended consequences, could amplify existing biases. And that's how I started working on this particular issue of unfairness through machine learning.
Okay, I think I should take that on now. So the beginning of my story is a bit like an accident or incident. Was that like I was doing a class project, building a visualization tool, just our choice. And then I started to figure out that I'm not seeing all the posts of my friends on Facebook. And then I thought that, okay, let's just make a tool that I can see what I missed. And I just made it as a fun tool. But then later when I was sharing with my classmates and friends, they had no idea even that exists, that many of the friends posts are removed. And then they were all CS bright students. And I was like, what's going on? Why they don't know? And then I started doing some informal talking with other people. And it turned out many people don't know, at least in my small sample. And then that was kind of a beginning of the idea of like, these algorithms are so embedded in our everyday social life online that people might not look into them or just even don't know they exist. So that was kind of the beginning of that. I thought that it's going to be a fun project. I didn't realize that so many people don't know about this. And then I found that we probably need not only awareness about how these systems work and they might introduce bias, but even about the presence of these systems and how they affect the way that we consume information. And the second one that, because that was more about the transparency and opacity of this system, then I started to be interested in the bias because I started to be the victim of one of these biases, one of these algorithmic systems a few years ago. And I realized that how this is serious and how can it impact people's lives. Not that I didn't know, I mean, when you experience something, it's just different. And like, it just encouraged me to continue in this area and focus more on bias, not just transparency, because transparency without understanding the back end of a system and if they might introduce harm to users would not be enough. So that's kind of the two stories shaping my path to where I am today.
That's great. I'm curious. You're working in the super. I think of it as a super difficult area compared to like a lot of us work on, where the answers are a little less clear. Like, what is fair? Okay, I'll solve that in a week and then move on. Right? Like, you're working in this very difficult space, but you're also working a little bit in opposition to computer science, or like maybe what computer science has traditionally been. It's more like, can we do this at all? Not, is doing this harmful, right? That's not typically been a question. And I'm curious if you've had some pushback, or like, what's the reaction been from maybe the more old school folks that you've encountered throughout your career already? And sort of what surprised you about the reactions you've received? Motahhare, do you want to take this?
Yeah, I'm up for this question. I got a lot of that. So I'm really happy you asked, John. So when I started this area, it was like 8 years ago. And I know now this bias and fairness in AI is really hot, like transparency, explainable AI. It wasn't the case that time. Even when I remember when I would write a paper, my lit review section was really short. I couldn't find like even work in this area. I mean, there is a full line of literature in bias in offline world, but people were looking at AI systems and algorithmic systems pretty objectively. And one of the pushbacks I got, which was really stressful during that time, is that I was in my second year or like third year of PhD. I was having a talk in our seminar, and they were very, very respected senior faculty that I still respect them very well, very much. And one of them though asked these questions at the beginning of my talk. It was about that newsfeed tool that I built to show people what they see. And then we were trying to show even how the algorithm might work, how much transparency it was needed. And I got this question, which shocked me, but also really helped me over the time. So I'm really thankful to that like question that made, because it was my default that it's important, but then they asked they asked this question that, why do you think it's important to know how these algorithms work, or like if there is problem with them? Because you look at our cars, we drive them every day. We don't have a clue how the engines work, and we are totally fine. So how do you make this analogy that these are like our engines of online life, you know, these, and they are all over the world, and people can't really understand them, and why even they need to know anything about them? And that time I was definitely not an advocate of full transparency, but enough transparency is something that I advocated and I still advocate. And honestly, I couldn't answer. I was like, I don't know, but there should be a difference. So this pushback was going on for a while until at some point I realized I know the difference. It was like, I don't know, one day you get up and after 4 years of research, you're like, oh, I know there are differences. So the first difference I found, and I came back and in a discussion with the same people who were like pushing back, and I think they were convinced that the idea was that, you know, when your car breaks, you know it's broken, like it caught on fire, like it doesn't work anymore. But we have many algorithmic systems out there. They are broken, they are conflicting, they're inflicting harm on people, and no one knows, because no one even like understand what's going on. And the other thing is that when these cars, like in our everyday life, breaks, we know where to take them. We just take them to our mechanic. We call our insurance to tow them. What do you do? What a regular user would do when a system is broken, like when they find a problem, when they see a harm is inflicted on them. And I think it took me time, and I really appreciate my advisor support, because she told me, don't worry. I was like, people are laughing at me. You can't believe it. People are like, what do you say? Like, this is a black box. There is a reason it's a black box. And she was like, you know, when the social computing area started like 15 years ago, people were laughing at us too. So like, why we need to analyze social media behavior, like things like that started the social computing area. So I think any area that wants to start are going to get pushed back. And I'm really happy, John, you brought this up to just the students know that new ideas, not that all the new ideas are great. Like I definitely have the share of my crazy ideas or silly ideas, but I think that's something that we should know and consider when we want to push things forward.
Hoda, do you want to share your experiences?
Yeah, so one of the common questions I often got when I started talking about fairness, and over time, I feel that the awareness has definitely increased. And I think the way I see it, that awareness is one of the key points of this type of research. As you were mentioning, you know, traditionally as computer scientists, we are very much focused on whether we can do something and what's the most efficient way we can do something, as opposed to whether it's ethically a good idea to do something. So that awareness is definitely increasing. In terms of what in the early days of this type of research, one question that I kept getting is, the machine learning system is just a mirror. It's just reflecting what's in the data. So it's not really about machine learning. Why are you bringing in machine learning into this? This is just a mirror. If society is doing something biased, of course, the machine learning system is amplifying that and reflecting that. So yeah, so in terms of answers to that, of course, that's one of the major sources of unfairness and bias through machine learning. It is, one thing is that it's not just reflecting, it can amplify, and as Motahhare mentioned, it can definitely, it really impacts people's lives in highly consequential domains, and it definitely leaves a long-lasting mark on people's lives. So that's one thing. And the other thing is that that's not really the only source, right? So even if you have the perfect data reflecting the perfect society, the perfectly just society, it is still possible for your model to come up with to produce biases of its own. For example, by the way it distributes different types of errors. Imagine a setting like the criminal justice I mentioned in my talk, where the cost of a false positive is much higher than the cost of a false negative for the individual who is being judged by these systems. So if my system, because one group is minority, one group is majority, or one group is being unjustly, put in jail more often, ends up making more errors, more false positive errors on one subpopulation as opposed to another, that's a form of bias it's introducing. And then, of course, there are all sorts of unintended consequences of these systems that have been in the news. When we deploy a system with the best of intentions, it ends up doing things we had no idea, Tay AI being one example of that.
Right. So we're getting some questions from the Q&A system. So let me just share something that came through. This is for both of you. Your work is so interesting and important. How can alumni or industry partners support your work, whether it be through funding or in some other way?
I can start taking that. So definitely funding is the standard way of supporting any kind of research. But I think in addition to that, one issue we have in this domain is that because of the sensitive nature of the analysis we do, and the fact that a lot of, a lot of companies, institutions that work with these types of systems don't want negative publicity, we have a data issue for sure. So that is one very much appreciated way of supporting this kind of research by allowing this type of analysis being done in real world domains without having to worry about sort of how it's going to translate into negative. Of course, there are understandably there are trade-offs. There has to be, there has to be negotiations taking place as to how the data can be used and cannot be used, but that's one issue we have in this domain.
Yeah, and adding to what Hoda said, in addition to the funding and data, one other thing is that it's because, again, like as Hoda said, it's a very sensitive area. We get sometimes pushback from industry working in this area. Like whenever I'm doing an audit on algorithmic systems, I'm like, oh, who is going to come after me after this paper is published? And I think this is also because of the lack of right regulations and companies comply with them. But at the same time, particularly if this is for industry partner, is that they need to see that this is going to help them in the long term as well. Like, like they need this AI bias type of research and auditing and working on design of the systems, because that's going to affect their own users, and the users are going to give feedback to the system about that. So something was I've been trying for the past few years, as also John mentioned. After I postponed my start date at CMU to go to Facebook, trying to build these bridges, like trying to show the industry community that we need this research there. We need transparency research, we need bias and fairness research. And it's hard. You've heard bad news about how things are going on AI fairness in some of the companies and just in general in tech industry. But I think one thing I really think they can help is that try to make these bridges by maybe having more discussions, collaborations, and definitely data and funding could be different ways of doing that.
But yeah, I mean, you're touching on this a little. I'm curious what your thoughts are about what's happening at Google with like losing a number of the leaders of their AI and ethics team. Is this sort of bad news for support for the work you guys are doing?
Yeah, it is, because we recently with like the collective audit work that we are doing, we recently, and Hoda actually getting a very similar support from the NSF is doing a joint program with Amazon on AI fairness. They call it Fairness in AI. They call it FAI. And we got supported by Amazon, like kind of like about a third of that is coming from Amazon. And now like we got it support from Cisco. And I'm thinking that how it's going to affect if they feel that the research we are doing might harm them, because we clearly said that we are going to audit many systems. And I think what happened at Google is so unfortunate, and it's a very controversial topic. And what I can say is that it definitely has discouraged many of my colleagues that I know working in this area, either like they are in job market or they are in academia, that we want to collaborate with industry to do that. So that's definitely discouraging. And I see less trust now in general community, research community to this, to the industry community. And I don't know what's the best way, because I know really great people that are still in industry, and some of them, they want to leave, some of them want to leave, but some of them, they think that a change is
needed from inside, you know, like you have to be inside to be impactful, like understand both sides, like those who want to leave or stay. But yeah, that definitely has caused some backlash. And I mean, I don't know if it's the right place, but we have Timnit Hebrew this week
Oh yeah,
as
coming
our
next Friday.
yeah.
Yeah, tomorrow.
So yeah, so we have Timnit coming, the former lead of like AI ethics in Google, in this Friday, tomorrow actually, at the HCI seminar. So I think she would have better answers definitely to that. So yeah, I would invite everyone to attend. I think that's public. Yeah, everyone can attend. I mean, as long as you're in CMU. So
Yeah, so I have a question for Hoda. Somebody's asking if 10712 fairness, explainability, and accountability is going to be offered this fall.
I'm not sure if it's going to happen in the fall or in the spring semester, but hopefully one of the two. As far as I know, that's very likely. We have, of course, internal departmental considerations regarding teaching assignments,
Sure.
which course need staffing and so on. So I can't be 100% sure, but very likely in either one of the.
Can you share a little bit about what students would learn in that class?
Yes, so that class is mainly focused on the technical aspects of the fairness debate, in particular, what are some of the algorithms that have been proposed to remedy some of the sources of unfairness. We learn about different notions and measures of fairness, how different algorithmic methods could help or hurt those notions of fairness. We will talk about trade-offs, impossibilities, and so on. The other two components of the course are explainability, again, technical methods for explainability. This next time I offer the course, I hope to be able to spend a bit more time on the human aspects of explainability, how usable some of these explanations are, and then we spend a little bit of time on accountability and regulation for AI. So those are the main topics that are covered. Yeah.
So I have a kind of controversial question for both of you. I'm going to make the assumption that you both think students should be learning about ethics and bias and fairness as part of their computer science education. This should be core. So if it's core, thinking back to your own undergraduate computer science education, what would you get rid of? What wouldn't they learn to create space for them to really learn this? Kind of inadvertently pick on someone who's teaching something, but I'm just curious, like from your own recent experience as students.
So the fun part is that Hoda and I share the same university for our undergrad. And I can think of not useless, but the courses that were not relevant to me, you know, like to my main. So to be honest, for example, we had to, and I don't say this is the same here in the US, but in my undergrad, we had to, for example, we had software, hardware, and IT like majors, and then like in undergrad, which is different here. But then, like for example, many of us had to take some hardware courses, and like, you know, like, which if you don't want to really go to hardware, it's not probably necessary. Like if I want to be on like the software or like IT, I needed to learn more about it. I understand that why they wanted we have a breadth of understanding, but I can see that less relevant courses to the area that a student or particular undergraduate students want to follow could be the courses to be replaced. And it doesn't need to be many courses. I can think of one course or two courses to do that. The good thing is that we did have ethics in undergrad. So, but only in a very focused major. So it was an optional class. And that time AI wasn't the thing probably that time as much as it's here, as it's now, but still it would cover a part of that. The other thing, which I think is a better solution, is that embed ethics in every course that is relevant to this topic. You know, rather than like we have a separate course and like, it's like, for example, if Hoda's course is for now is about fairness. But for example, I'm teaching UCUR, which is user-centered research. an evaluation. And we are trying to talk about bias in the course because, the bias can run into even when you do interviews or you build systems, like when the students design systems. So we are trying to add more material to that. So I think that should be the goal, not removing some courses. But if we want to remove it, still, I can think of some to remove.
It's an ongoing argument, if you work on curriculum for long enough, every time you want to push something in, you really do.
You have to, yeah.
Take something out, and then how do you decide? But I'm just curious, again, from your own experiences, do you want to share anything?
Yeah, so I think I'm going to try to give a non-controversial answer to that by saying that we could maybe take away from the number of electives and push this into the curriculum. The other idea would be to maybe reduce the number of credits of some of the courses as opposed to entirely, removing them from the curriculum. Another very practical solution is to just ask students and also our industry partners, what are some of the, courses that they think are key and they should stay, and what are some of the things that could, for example, become an elective depending on the career path the student is imagining in industry. So so these are some of my answers as to how we can do this. Regarding Motahhare's suggestion, I definitely like the idea of embedding these into all courses. But I think still it's important to have a course that focuses on these issues. It's definitely helpful to see them in particular, how they show up in particular computational considerations. But it's also, I think, useful to have a more focused study of these next to each other so that they get a broader picture of their potential impact on people and society.
So I want to get a sense in the work that you're doing, how do you play with this notion of how good is good enough? Like, what is a meaningful increase in fairness? I mean, we typically measure with some value of some point, and it's like, oh, 0.3 better. But how do you sort of practically say, this seems like it was a practical improvement versus I can show statistical significance, like, and with something as slippery as fairness, how do you put your hands around that?
Yeah, I can start. This is a very good question, and something that I always try to be careful to mention, that we should really treat all these existing notions and measures as those of unfairness and mainly used to audit as opposed to going for perfect fairness. That there is this notion that I'm algorithmically guaranteeing my tool is not is fair according to that. Now I'm good to go. That's not the way it should be. It is always about comparing with alternatives, understanding which one is the best among the practical alternatives we have. Even if you think about, a practitioner, when they go about doing their work, we can't tell them, well, the model you've deployed, forget about it. Let's now come and do this fairness constraint, add it, see what you get. That's usually not how it works. It is going to hurt accuracy. It is going to have all sorts of ramifications. So the way we can do this is that among the, practical alternatives you have, which one seems to be more reasonable? And part of the work that I've done is precisely addressing that question of measurement in a way that we can compare these different tools in terms of their overall unfairness. And as I mentioned in the talk, I've tried to bring in some axiomatic way of thinking from economics to this notion. But in general, I think the broader point you're getting at, which is this issue of turning our moral judgments, our ethical desiderata into numbers. This is extremely challenging. It is never a perfect mapping, but again, it's a matter of practicality. If we are automating some of these ethically consequential decisions, we'd better have a way of at least auditing them.
Yeah, second thing what Hoda said, that comparison is a way, because, you can't really have one perfect definition. You just need to figure out what are the practical ways. The other thing that I think you, John, and I also discussed in detail is that bringing awareness, not just fixing the bias, because I don't think any bias could be fixed completely. And I mean, it's just the nature of dynamic and complex complexity of these systems that when you remove a bias, as like Hoda mentioned in her talk, is like when you remove one bias, another notion of like fairness or a bias is in conflict with that, so another one might come up. So the idea is that sometimes when you want to evaluate, and because I'm focused more on the human side, is that to understand if humans' performances change based on either you mitigating bias or also informing them about that their decision might be informed via a bias decision, algorithmic decision or algorithmic suggestion. So they know what they are getting into when they make a decision. So, and then the measurement, in addition to quantified measurement, is also the human decision makers' performance over time, and also the other stakeholders that are get affected by these decisions. Like, and that's the hard part. It's just some of these are long-term, and some of these are hard. For example, we had this discussion with one of my colleagues is about how you can say a pre-trial risk assessment tool is a good one, because what if it just says, recommends that someone doesn't go to jail and then they commit murder 5 years later? Can you tell that was the reason? Like, you know, like it's just hard because these systems are not working in vacuum. They are working with a lot of like social dynamics. So I agree, John, this is hard. This is an open-ended question, but I think comparison and finding practical solutions, practical ways and compare them as well as bringing awareness can be a way to understand if there is improvement to the system.
So we're nearing the end of our time, but we just got a new question. So I'd just like to take this as our final one. And this is, most of the work done in FAIR ML is mostly in an American European context. Do you think that algorithms designed for the Western world could harm people in other cultures? I'm just curious about your reaction to that.
Yeah, I totally think it can can cause harm. And actually, I've seen evidence of that. One recent example was that there was an image tagging algorithm that turned out to label, could not label Asian people well because it was not designed well. Or also there was another one that would tag every religious place, like if it's a mosque, if it's a church, if it's a synagogue, if it's for Hindu people, it would just mark it as church. So you can see this is a very simple example, but how it is like, because of the blind spots the designing team members have, it's just going to creep into the system. And I think how we currently deal with that, I think one thing I know that industry companies are trying to do is diversify their team or perspectives or auditing their teams. But I think we need to understand these problems first. Like we don't know even different types of bias happening if we don't have the right users using the system. But that problem definitely exists, and we need to think about how to solve it.
Great. Hoda, do you have something you want to add?
Yeah, so I would just add to that that you're absolutely making a very important point, which is that when we think about bias, unfairness, discrimination, these are always context dependent. They are inherently, they have to be inherently understood, situated in a particular context, in a particular society, right? So we always, when we talk about, for example, group level notions of fairness, we talk about the concept of social saliency, right? What groups do we even consider salient for in the context of criminal justice? That has come to be as the result of a very complex history, right? So, and that is an American history that we are dealing with. Whereas if we are thinking of the same tool in a different country, deployed potentially in a different country, our considerations could be entirely different. So you're absolutely right that these are very context dependent methods.
Great. I'm getting attacked by beeps here. I want to thank you both and let the audience know that this recording is going to be posted so people can see it, particularly if they couldn't make it. But also, I want to encourage you to follow up with Motahhare and Hoda, who are new here, but soon we'll all be back on campus. So hopefully they'll become very familiar faces to everyone. All right, thank you.
Thank you so much, John.
Thanks, everyone.